Welcome back to another episode of the React Native Radio Podcast. Episode 355, React Native Skia with William Candillon.
And welcome back, React Native Radio fans. My name is Mazen, she's Robin, and we're React Native Radio. We have a cool guest for you today, the famous William Candillon. William, welcome to the show.
Thank you for having me. Good to be here.
Yeah. Can you please introduce yourself to our listeners?
Yeah, so I'm William. I work as an independent software engineer in beautiful Zurich, Switzerland. And my work mainly is focused on React Native and GPU graphics. So Skia, WebGPU, anything related to React Native and graphics, essentially.
Nice. Spoiler into our topic today for Skia. Or should we talk about something else other than Skia and WebGPU?
Quick pivot.
Quick pivot, yeah. We'll pivot right now.
No, we'll stick with Skia.
Yeah. Before we get into our topic, let's hear from our sponsor. InfiniteRed is a premier React Native consultancy located fully remote in the US. We're a team of 30 senior plus level React Native developers and support staff, and have been doing this for over a decade. If you're looking for React Native expertise for your next project, hit us up at infinite.red/radio. Don't forget to mention that you heard about us through the React Native Radio podcast. All right, let's get into our topic, React Native Skia. Yes, we're not going to pivot. William, can you tell us a little bit about your background and how you got involved in this space? And, most of us I started PHP before I eventually landed in React Native. How did you get to Skia?
Absolutely. So I used to work for actually a database startup. So more like backend, C++ work. So this was already, I feel old now saying this, but that was like 10 years ago. So time flies. And actually when React came along, even though it's front end, it's completely different. There were some cool ideas about, dealing with changes in the reconcilier and so on, which I thought were actually very similar to things in databases. So it really caught my attention. I thought the programming model was very interesting. Then when React Native came along, I thought, wow, to apply this model to build native apps, I thought was something really interesting and powerful. So I decided to get into it. And so I started to work as a freelancer, building apps. Then, I was always trying to one-up myself and try to build these A-grade user experiences in React Native. And of course, back then we had little to no graphic primitives. And it was kind of fun puzzles so you have so little primitives, but sometimes it's nice to walk around the obstacle and try to find a way to overcome it. But eventually we switched from having fun with the obstacle to overcome it completely. Mm-hmm. And overcoming it completely was to bring the web graphic primitives to React Native end. So we looked at Google Chrome. Google Chrome is using Skia as a graphic library. Mm-hmm. So that's what we're going to do. And for us, a pressure point that really triggered me to go to having fun with the obstacle to overcoming it was really Remotion. So I was doing these YouTube tutorials. Can it be done in React Native? Having fun. I was not thinking about anything else. And then I started to use Remotion so to make videos with React. It's a really cool project. So it's like After Effects, but for programmers. And here it's using a web Canva. So I was making my React Native videos and then using a web Canva on the side, which was so much more powerful than React Native. Mm-hmm. I was like, oh, okay, no, this cannot hold anymore. We really need to have the parity level with the web. And so that's how the React Native Skia project got started.
I remember trying to make a triangle in React Native with just CSS styles. I was like, this is not going to fly. So yes, we probably needed a real graphics library.
Yeah, I want to shout out your series, Can It Be Done in React Native? Because I will tell you, when I first started my career in React Native and I needed animations, that was my go-to to kind of see how it's done and how it's done well. And for a couple of my apps that were in production at that point, they had your animation in it. So thank you very much for that.
Thanks, I appreciate it. It's really cool to hear.
I think a lot of our audience have probably watched your YouTube tutorials. I know I have. So let's like go like to the basics a little bit and tell our audience just about what Skia is. Like setting aside the React Native for a minute, but what is the Skia graphics library?
It's a C++ graphic library, 2D graphics, that is built by Google. So it's open source. Google uses it almost everywhere where they need to display pixels, so whether it's Android or Google Chrome, there are other products. It does a lot of stuff. So for us, you can draw paths, SVGs, and have like effects. It does also an abstraction of the different backends. So different devices use different hardware and drivers for 3D graphics. And it provides a single API on top of whether it's OpenGL, Metal on Apple, and so on. And it allows you, so it has a shader language, which is close to the OpenGL shader language, where you can write custom effects. Mm-hmm. And it's going to be compiled automatically to whatever the best backend is, whether it's Metal for Apple devices or OpenGL for Android or Vulkan for a more modern Android device.
Yeah. I'm sure it has to have a pretty like large API like surface area in order to like be the driver behind things like Chrome and Android and stuff. So I imagine it's a pretty extensive tool and pretty hard to learn like the whole of it and be really good at it.
Absolutely. And when we got started, so we were two people working on this project with Christian Folk, and we didn't know anything, right? So we had this large API and we were not sure what to use, what not to use. And our guiding star was kind of, it is still used in the Flutter product. Mm-hmm. So we looked at the Flutter drawing API.
We don't say the F word around here.
But so we looked at the drawing API, how it was structured, and we used this as a symmetry. Of course, now this was 4 years ago. Now we understand, we know how it works. We would make the API to React Native slightly different. There is also some naming issues, and all these issues kind of come off from the start of the project, where we were not sure what we were really doing. But now we know what we are doing. So some API namings and some APIs would be very different today if we were to start again.
So Skia is a canvas, like it's a canvas like rendering system, right?
Yeah.
Which means that you're telling it like how to draw something versus like telling it like, I want a square. You're saying, okay, here's how to draw like the square that I want. Is that right? So it's like imperative versus declarative.
Yes. When you have drawing APIs, usually there are two modes. So one mode is called immediate API. So you say draw a circle and it's going to draw a circle. And then if you want to change the color of the circle, you say draw a circle red. Mm-hmm. So every frame you tell it what to draw and it's going to draw from scratch. So that's immediate mode. And then there is another mode which is called retained mode, which is more like DOM style or React style, where you say, okay, this is my drawing, it's a circle. Now let me update the color of the circle.
Okay.
And so you say props goes from red to blue. So it knows already that it needs to draw a circle, and now it knows how the property has changed. And that's called retained mode. And so Skia is a C++ API which works in immediate mode. So you just every frame tell it what to draw. But because there is a cost of communication between JavaScript and C++, we offer retained mode. So our goal is to minimize the communication between JavaScript and C++ as much as possible. This is how we achieve close to native performance. And so we've built on top of it a retained mode where the native side knows about the drawing. We just tell it what to update on every frame, and it's very fast.
That's a really good segue into now adding in the React Native part of React Native.
Yes. So as we add in React Native on top of Skia, because it's written, like you said, in C++, the React Native side of things is, correct me if I'm wrong here, it's native, right? It's a native because it's C++. It's written in that low language.
Yeah.
And you're just writing the bindings from C++ to kind of bring it up and expose it to the JavaScript layer as components or as functions.
Exactly. That's,
Yeah. Awesome. Yeah. And one thing I also wanted to mention, talking about like canvas-like rendering, one thing as a developer you have to always provide is you have to provide coordinates, right? You can't just tell, hey, draw me a circle. You'll just kind of draw it in infinite space. You almost tell, hey, draw me, circle's probably harder. Let's say a square. Draw me a square starting at 0, 0. So that's, top left. And then you tell it to go X pixels to the right, Y pixels down to get you your square or rectangle or shape, right? So that's kind of where the whole coordinate part of canvas drawing can get a little bit complex, right? If you're trying to draw a circle, you can easily draw a little squishy circle. What's a skinny circle?
Yeah.
An ellipse?
An ellipse.
Yeah. An
An
oval
ellipse instead.
or an ellipse.
Oval. Yeah. As a developer, if I'm, whether I'm a beginner, let's just start with beginner level. I'm coming in, I want to do canvas-like rendering on my app. What concepts do I need to learn to kind of to do this? Like, what's my entry point? Is it easy to kind of get into? Just read the docs and it's very self-explanatory, or is there some other graphics modeling that I have to kind of understand first before doing this?
So there are a couple of things. So there are two things I would say. I think often developers, they work with designs that, let's say Figma designs. And here I would say we map pretty well the Figma primitives. So whether it's a blur or a complex gradient or a complex, path Boolean operations or anything paths related, we're really mapping one-to-one with what Figma is offering. And then I would say that's part one. Part two is, so if you want to build these complex custom effects, you need to go into the world of shaders. And shaders are these programs which gets compiled to the GPU and gets executed on the GPU. So here the paradigm is a bit completely reversed. So we said, draw a circle. But in a shader, it's the other way around. A shader tells you, this is my XY coordinate. Yeah. Now, am I part of the circle or not? So you need to answer the question backward. And it's a very, very interesting topic.
They're used a lot in gaming. I hear shaders referred to in gaming a lot more than regular React Native programming. So
yes, absolutely. And it's a very hot topic, and there is a lot of because it's almost completely a complete different world, right? So it's a different language. The paradigm is different.
It's just a different way of thinking about how you're telling the computer what to do.
Exactly. But there are a lot of interesting things happening on this side. So first of all, there is a community called Shader Toys where people share examples, and these work almost out of the box in Skia. So you can browse these incredible examples, you can copy paste, and sometimes there is tiny changes that you need to do because it's a slightly different program language. But the LLM usually is going to fix it 100% of the time. And it's just also a fun community of really people who are so passionate about this topic. Lately, it has been one of my favorite community. So there is a lot to learn here and a lot of fun to be had with the shading community. But I don't know if you guys have heard about things also like Type GPU, which allow to write shaders in TypeScript from Software Mention. Yes. And I've played with this project recently, and I think it's kind of really cool because now it's also bridging the gap because you write your shader in TypeScript, and developer experience is pretty close to a pure TypeScript experience. So the same way you write your worklets function in TypeScript, in JavaScript, TypeScript, now the same is happening with shader. And so that's very cool because now it's the same language, same userland. And then we mentioned the thinking model being, reversed, where it's not draw a circle, but it's like, am I a circle or not? And actually, we might offer some things in the future that might help with that. So,
spoiler, it seems like...
So it's a fantastic topic.
Yeah, we'll talk about that in a little bit, I'm sure.
Yeah.
But I want to talk about our audience being React Native app developers primarily. We're primarily React Native app developers, and we do a lot of pretty standard apps that are like data in, data out, like lists and sort of very standard stuff. Is there where in my sort of standard React Native app, am I going to see the most use for something like React Native Skia and like these complex graphics and stuff? Like, is there anything beyond just like a loading animation or something like where I would get a lot of use from Skia in like, or do something that's like impossible to do with React Native components?
So personally, as a mobile, when I use my phone, sometimes I go on apps and there are some user experiences that are really genuinely delightful. And sometimes there is this button you press and you just want to press it again just because of, how it felt in the, maybe there's an haptic feedback.
Yeah.
And when these experiences happen, if you want to build it in your React Native app, most likely you're going to need React Native Skia.
Yeah, right. You're just not going to be able to achieve the level of sort of like delight with just plain React Native components that are very much more static.
Yes. Sometimes you need complex geometries, some glow effects. You need the colors to follow the geometry, things like this. You're going to need advanced graphic library to a liquid glass effect. I don't know, something.
No, and that also just, for me, brings up charting libraries, right?
Yeah,
like,
absolutely.
Skia is a good example of a way to write your charts because it's, like you said, delightful. You can kind of like animate your lines to look, wavy or whatever as they're coming on. And then, maybe they're colored and stuff like that. So it gives you that like nicer look than just like you're reading a chart on an Excel spreadsheet, right? It's like, it's giving you a fancier chart.
Some of us like Excel.
It's so funny you say that because as I was answering the previous question, the example I had in mind was the RNR app, which is very popular in Europe. And I was thinking about how they show the running stats. And there is like these beautiful effects around the charts, around the running statistics. And that's actually the example I had in mind as I was answering. So to your point, yes.
That's a very good example app because you're right. That's 100% React Native. It's correct me if I'm wrong. It was bought by Strava, if I'm not mistaken. If you're a runner and you're listening to this podcast and you're not using Runna, I would recommend you do. It's a RUNNA. It's a very delightful app for running, and it's built in React Native. And they use Skia, I assume, for that kind of stuff. Now, can we take that a level deeper as we think more about user experience? Like as I'm building these components in Skia, how's the performance? Like, are you all like using, now we talk about the current architecture, no longer the legacy architecture. The architecture, right? And we got Fabric and Turbo Mode. We got all these, fancy stuff here. Has this new architecture or the current architecture unlocked the possibilities to where you are building performant components basically without even like pushing the limit almost, if that makes sense?
That makes a lot of sense. And yes, absolutely. So for us, I was about to say the new architecture. For us, the current architecture has really enabled, and it's funny because it's actually such a simple feature that it gives us, but actually for us, it's completely transformative, and it's just the access to synchronous layout. It might sound so silly, but for us, the fact that we can now access the layout synchronously, so ask, okay, what's the size of the Canva in a synchronous way, has unlocked many, many things. And mainly it has unlocked for us WebGPU. And with WebGPU comes a whole bunch of improvements that we could get into. And the second, I would say, I'm thinking about two things related to Skia and performance, which are a hot topic for us. So the first one is that more on the native side, so native meaning platform native, so Android and Apple. So people, they use Skia across web, iOS, and Android. And so the expectations of the platform are different because if your Skia drawing behaves a certain way on iOS, you have the same expectation on Android. But the Android graphic APIs, Canva API and so on, behave very differently. So for us, a hot topic is to try to always match what you can do on a web Canva element, what you can do on an iOS Metal View, or what you can do on an Android surface. And the second aspect is so more on the native but cross-platform native, so the C++ layer, which is the same across Android and Apple. Here, there's no platform differences. So for us, as I mentioned already, the heart of the matter is really performance, so meaning having a cost of communication between C++ and JavaScript as low as possible, and to have fast memory management or very efficient memory management. So it's also a topic because JavaScript is garbage collected. We use Hermes is the default. I think that's most likely the only JavaScript engine that runs with Skia. Yeah. And we need to tell it because also it's these C++ objects, which are also bound to GPU resources. And we need to tell it how much memory we think they take in the app. And we need this to be garbage collected efficiently. So that's a very hot topic also for us related to performance.
That's very, very helpful because, if any of our listeners are looking for some of these like cool animations and to do, or even just displaying like beautiful UI like you did. I believe I saw you posted a video of like a backdrop that looked really nice. And that wasn't a lot of code, but that also seemed like it wasn't, from what you explained, performance-wise, it's not taking a hit. So to get something massive like that on the screen is not necessarily taking a big hit on the device, which is great, which is, unlocks a lot of possibilities when it comes to this stuff. You've mentioned it a couple times now, and I want to come back to it, and I think we can kind of give it its space now. What is WebGPU and how does it fit in Skia?
Yeah, so it's interesting because we were working on React Native Skia, and I wanted to do always more and more complex things with it. And I did, usually for April Fools, I do a joke video, but usually there's like a serious technical content behind. And I wanted to make this 3D cake using Skia, but of course it's very complicated because Skia is not a 3D engine, it's a 2D engine. So you have the faces of the cake, but so you need to do a 3D projection. So first you do it in your React component, where it's something that would happen on GPU usually. And then you need to sort, when you see the cake slice, you need to sort the faces of the cake. So the face that is behind is being covered by the other faces. And this, again, we do it on CPU, where in a real 3D API, this would happen on GPU. And I was thinking that's really, really strange because I know that Skia runs on 3D APIs, namely OpenGL or Metal on iOS. So I know these capabilities exist. They're just not available to the API. And this is what led me to WebGPU. So WebGPU is a cross-platform 3D layer. I mean, it's 3D, and also there is another path which I can talk about, which is compute. This allows us to have 3D and 2D in the same environment. And I shared this week a demo on Twitter, which is a rotating cube. And you have on one face of the cube, you have a video playing. On the other face, you have a Skia demo. On another face, you have a paragraph layout, text layout with native emoji, fonts, and so on. And this demo was really to show, okay, now everything is running under one runtime, and it's WebGPU. And this is also what the web is doing now. So the web is going towards WebGPU, and even libraries like Free.js and so on are based on WebGPU. So that's really the future. So we follow the symmetry with the web, and that's also, I think, going to be the future for React Native. And that allows us also to run libraries so all these big web libraries from the web ecosystem, we can bring it to React Native. Yeah, like Free.js, for instance, it's a really big one.
So is this going to really open the door for like for apps to really be completely cross-platform? Because I mean, like, most of the projects that we're working with now are trying to do web and mobile in one code base. Does this like help with that, sort of like really being like truly shared code bases that are using Skia?
I think so. And again, going back to the topic of the current architecture, which on the web, you always have the Canva element. And this Canva element you could do with height, get context, get graphic context, and this is my width and this is my height. And this is what the current architecture allows us to do. And it might sound like a small thing, but to be able to have such symmetry with the web comes a very long way for us. And especially being able to copy paste. So you go on webgpusample.com, you copy paste the example, you paste it into React Native. It just works. It works. It's exactly the same. So it's very cool. And the other path of the library is that you have a path which is graphic pipelines. And then there is another path called compute shaders, which allow for general purpose GPU computations. So anything that needs to run on the GPU, like a machine learning model and so on. And so that also enables a whole bunch of new use cases potentially in React Native.
Yeah, I think for our listeners, one thing I want to highlight is please check out the show notes when this is done.
Mm-hmm. Yeah, we're linking to everything that we've talked about.
There's a lot of information that's going to be in the show notes because like even just you mentioned the WebGPU samples, it's cool stuff. It's like stuff that you could do. And, you know, one thing that I saw that just made me like think like, hey, there's a lot of apps out there. There aren't a lot of mobile apps out there. There's web apps about flight tracking, right? And like watching a flight go from point A to point B, but there's no mobile one. I'm always having to go to, you know, my browser on my device.
Are you telling me you don't have Flight Radar downloaded on your phone, Mazen?
Well, are they? And here's the question I say to Flight Radar, if you're listening for some reason. I don't think you're React Native. Are you using Skia and some of this WebGPU stuff that, you know, in one of these articles, you can actually see a planet with like point A to point B and kind of like the flight path.
Okay, they don't have that. It's very like flat.
That is something cool. And that's like a next level user experience that you can do. But like William, like you're saying, that's all done in WebGPU, which is web, quote unquote, standards, giving you native performance. And that's huge in my mind. That unlocks a lot of potential, a lot of things that possible to do there.
Absolutely. And I'm very excited and impressed by the technical potential of WebGPU. And it's interesting because I meet people who are as excited as I am. And what's interesting is in this discussion is that they come from the game dev community. So they are game developers. And they get I get genuinely so energized about these topics. And I can see that they match my level of excitement. But what's interesting is that when they talk about the use cases and the possibilities, it's always in the context of a game. And me, I'm always like equally as excited, but in the context of user interfaces and React Native user experiences.
Yeah, that's awesome. And you recently did a video that I actually watched and I really liked, your shaders gambit, where you built the
chess.
queen, the chess piece in it. And that was really cool to see like how you had a smooth surface and you just brought a circle and kind of like squeezed that part of it and kind of gave you the full texture look of a chess piece. And that was all done in WebGPU. Is that correct?
So no, but it links to WebGPU. So this was done in Skia using a shader, but actually there is a strong link with WebGPU. So the way 3D graphics are usually done is you just basically render a bunch of triangles. So you say, this is my geometry, my triangles are positioned a certain way. So in the case of the chess piece, you would have a 3D model that gives you all the polygons and triangles of your chess piece. And then you have a shader where you decide the color you give the triangle, and you can do lights effects, and so on. And in the shaders gambit, we use the different approach, which is we don't do any triangles. We just use a shader and mathematical formulas to describe the shape. And so this complex shape, so you do a cylinder, there is a mathematical formula to draw the cylinder. So if you have a point in space, you say, okay, how far am I from the cylinder or not? And then the trunk of the chess piece has a special form. And then you say, yeah, of course, my radius on the cylinder is not a constant value. It follows a curve, right? And that's how, and then you build the chess piece by also subtracting shapes with one another and so on. And so that's another path of building 3D model. And the link with WebGPU is that in WebGPUs, as I mentioned, there is this general purpose GPU computation path. So you can do graphics, or you can do this these compute shaders. So general purpose GPU computations. And the very exciting topic for me at the moment, and that came from this shaders gambit video, is that, okay, let's use the non-graphic pipeline, but to do graphics. And then what can happen there? And actually, it's such an exciting topic because you can do really genuinely interesting things. which I'm going to get to talk about very soon. And I'm very excited. And I know the Type GPU team at Software Mansion is also very excited about these topics related to compute shaders and writing them also in TypeScript and so on.
That's awesome. Well, I think we're kind of running out of time on this, but I think this is an amazing topic. Thank you for shedding all this light on this, William. And I urge our listeners, check the docs out, check the tutorials. There's a lot of cool videos on there of like stuff that you could do if you have a progress bar, if you have a chart, whatever it is. Like those examples are all there, and it's really cool scenarios.
And if I may add to see, because so we do the 3D chess piece, and this was for April Fools. And then you're thinking, okay, but can this be a serious thing, right? And then it's funny. So this was April last year. And then Apple, came up with liquid glass.
Yeah.
And in liquid glass, the way the buttons merge with each other is exactly using the formula, the mathematical formula that is used in the chess gambit.
They totally watched your April Fool's video.
You are ahead of your time.
What I mean is that, no, because here I'm just reusing, of course, existing opus of work. But first, it starts with a joke. But then if you think, but how can I use this seriously? You can do some really serious things with it.
Totally. Yeah.
That's a really cool story of how it sort of came to be from an April Fool's joke.
Yeah.
Awesome. Well, again, before we kind of wrap up, usually the question we like to ask at the end of these shows is, what's next for Skia? What's coming down the pipeline that you can share with us with Skia and WebGPU?
Absolutely. So it's really right now all about WebGPU. So running Skia with WebGPU, like I said, doing 3GS scenes where you have text layout and paths which are rendered by Skia. So you use each library to what it's best at, and you put it together. And we're also we're testing video support, camera support. We're working with the team at Margello who does vision camera. So also these things to talk to external libraries are becoming even easier with WebGPU because the threading model is much clearer. Because it's only based on modern GPU APIs like Vulkan and Metal, there is much more things we can do where right now with Skia, we're single-threaded. We have to use OpenGL on Android. Things are a bit more complicated. So this is really our focus. It's going to take some time to be completely migrated because, first of all, on Android, some devices don't use Vulkan yet necessarily. And also, so we use a version of Skia, which is called Skia Graphite, which is made by Google. And here also, there are things that need a bit of time to be mature, I would say. So it's going to take a while, but this is really where most of my focus is on. And,
that's awesome.
And I want to show also some of the new capabilities, some of the new effects and animations you can do with WebGPU that you couldn't do before.
That's awesome. Yeah, it's funny how Google software is having a hard time running on a Google other software, Android.
That's
right?
fine.
Android, always the problem.
It is a little bit
Android.
ironic, isn't it?
Just build for iOS and you'll be fine, people. I'm kidding. That's why we're here. Well, again, William, thank you so much for coming on to the episode. This was amazing and enlightening, and we really appreciate it.
Thank you for having me.
Yeah. Before we sign off, Robin, do you have a mom joke for us?
I have a good one from Gant. I took the shell off of my racing snail to make him faster, but unfortunately it just made him a little more sluggish.
Nice. Love it. Awesome. Thank you all, and see you all next time. Bye.
Bye.
As always, thanks to our editors, Todd Worth, Tyler Williams, and Jed Bartosky. Our marketing and episode release coordinator, Justin Husky, and our guest coordinator, Mazen Chami. Our producers and hosts are Jamin Holmgren, Robin Hines, and Mazen Chami. Thanks to our sponsor, Infinite Red. Check us out at infinite.red/radio. A special thanks to all of you listening today. Make sure to subscribe to React Native Radio on all the major podcasting platforms.